All right, let's quickly look at this math challenge before us here. This exponential equation. How do we solve this? X equal to 1 all over 4 to the power of x. I want to believe this is easy to solve. Okay, so let's take a solution here. Solution. All right. Now, if we look at this question carefully, what do we do here? So we want to eliminate this 1 and this division sign here. And so rewriting this is going to give us our x will now be equal to 4 to the power of minus x. Easy, right? Good. I just apply a simple law of indices. Then the next thing we're going to do here is to align both sides of this equation. We could as well use log to base e or log to base 10. But let's use ln base e. Okay, so if you use ln base e, we're going to have here ln of x equal to the ln of our 4 to the power of minus x. All right, so what we do here again now, this is an exponent. All right, so there is a law in logarithm which says that if you have your ln of a all to the power of b, say move this to this side, so this is going to give us b times our ln of our a. Okay, so we are going to put this law into use here now. We want to move this exponent here to this side. Okay, so this is going to give us our ln of x. Let's put this in bracket equal to our minus x there, or in bracket into dot our ln of our 4. Let's put this 4 in bracket. How we get is something from here? X. So what's the next thing we do? Let's eliminate this minus x so that this constant will stand on its own. Then bring this variable to this other side. So we divide through by minus our x. We only divide this by minus our x. This will leave. So we now have our ln of our x all over minus x. This is equal to ln of 4. Easy. Okay. So what we do? Here we are having ln of x. We want to bring something that will enable us to evoke what we call the Lambert W function or the product log into the system. And so what we do, we look into the denominator on the left-hand side of the equation. We can rewrite this denominator by introducing our e to the power of ln. We know that if you have your e to the power of your ln of, let's take a star, because I prefer using the star. This is the same thing as your star. It's equal to your star. Okay, this is another simple law again that we have to adopt here. So if we have this equal to this, we can rewrite the denominator here, which is the minus x here. All right, so let's continue on this side and see how we write this out. Now let's look at this carefully. Look at this minus sign here. We can rewrite the whole of this expression first before we bring in this system. So this is going to give us minus here. We're going to have our ln of our x close bracket all over x. This is equal to our ln of our 2. Again, let's rewrite this ln of 4 here. So 4 could be written as 2 to the power of 2. There's a reason why we are splitting it into that format, right? Okay, so from here now, we're going to bring this into this. So this is going to give us minus ln of our x bracket all over our e, all to the power of ln of our x. This is equal to, we bring this back according to the law of logarithm, which we just look at this guy here. So we're going to have here 2 times ln of 2. Close bracket. How are you getting something here? Yeah. Now we want to move this to this side of the expression here, eliminating this division sign here. Okay, because we know that we can rewrite this as our minus our ln of our x times 1 all over our e r to the power of ln of x, close bracket, right? Which is equals to 2 times the ln of our 2 here. Now, according to the law of indices, here we can eliminate this one and this division sign. And so this exponent will take a negative sign. So we're going to have this to be minus ln of our x bracket times our e all to the power of minus ln of our x equal to our 2 there times ln of our 2 here. Check out something here. What we have at the base here is same thing we have at the base at the exponent here. With this in mind, because we try to evoke the Lambert W function or the product log, right? So what we do, look at this. We can equally rewrite these two in this format too, bringing e to the power of ln of 2. Okay, so let's rewrite this side. So this is going to give us minus our ln of our x close bracket times e to the power of minus the ln of our x close bracket. This is equal to our e to the power of ln of 2 close bracket times the ln of 2. Okay, so if we rearrange this system very well, you're going to see that this is going to give us minus the ln of our x close bracket times e to the power of minus ln of 2 close bracket. This is equal to the ln of our 2, which is this, times e r to the power of ln of r 2. Oh, can we see something playing out here? Can we still see that side of the board? Yes. And so long what we have here is same thing we have here. What we have here is same thing we have here. We can now bring out the Lambert NW function, which says that if you have, let's put it here, if you have, let's say you have a star, I prefer using the star, times our e to the power of a star, and you decide to take the Lambert NW function, is going to give us a star. Right? So if we circle out to this rule, then we can now introduce that to this side. So let's do that. So we now have here the Lambert NW function of brackets our minus ln of our x close bracket times our e to the power of minus ln of where did I see to? This is supposed to be x list. So x here close bracket, close of bracket. This is equals to the Lambert NW function of our bracket, ln of our 2 bracket 2 close bracket times e to the power of ln of our 2 close bracket here. Okay, so with what we have here now, what happened? Then we're going to end up having minus ln of x equal to ln of 2. All right, so let's continue on this side of the board and see what this gives us in turn. So from here, we're going to have our minus ln of our x. This is equal to, here we're going to have ln of 2. So we have ln of 2. Good. How we learn something here? Again, according to that law of logarithm, which is the exponent law, we can move this because here we have invisible 1 here. So we can move it to the side of the equation of the exponent. So we're going to have here ln of our x minus 1. This is equal to our ln of our 2 here. So we have the ln of 2 here. We have the ln of 2 here. So both of them can cancel out, or we just bring in e into the system, whereby we now write e to the power of everything here, e to the power of everything here. On that ground, they will cancel out. So let's take that. Okay, so we're going to have here e to the power of ln of bracket x to the power of minus 1 close bracket equal to e to the power of ln of our 2 here. So this is ln base e, this is ln base e. So when I have our x, so we have x to the power of minus 1 equal to what? 2. What is x to the power of minus 1? This is the same thing as 1 all over x, right? So this is going to give us a x, 1 all over x, right? So we have 1 all over x. This is equal to 2 all over 1. So from here, if we cross multiply, what happens? So we're going to have x times 2 and y times 2. So this is going to give us 2x is equal to 1. All right? So from here, divide by 2, divide by 2, cancel out. So we now have, therefore, our x is equal to 1 all over 2. Wow! This is serious. So this is the value of x that satisfies the original equation. So if you want to do a simple check, you can do a simple check to this. If you have here 1 all over 2, this is equals to 4 to the power of 1 all over 2. And what is 4 to the power of 1 all over 2? That is just the square root of 4. And the square root of 4 is what? 2. So automatically we're going to have 1 all over 2, which shows that the root x equals to 1 all over 2 satisfy the original equation. So this brings us to the end of this math class. If you learned something from this video tutorial, give the video a thumbs up. Again, if you've not subscribed, do it to subscribe. And until we meet you in our next class, keep winning. And do not forget that Jakes does love you. Thanks for being there all the time. Bye for now.